GATE 2015 Set 3 EC question number 53. Consider the 3 meter long lossless airfield transmission line shown in the figure. It has a characteristic impedance of 120 pi ohms and is terminated by a short circuit, so ZL is 0 and is excited with frequencies 37.5 megahertz. What is the nature of input impedance is being asked. 4 options are given, whether it is open, short, inductive or capacitive. So you need to refer to lecture number 12, Impedance Matching of the NPTEL course Transmission Line and EM Waves by Professor R.K. Shivagaonkar, Department of Electrical Engineering, IIT Bombay, for more details on this concept. Now coming to the useful data, the input impedance of a line is given by its characteristic impedance times ZL, that is the load impedance by which it is terminated, plus ZC tan beta L, where beta is the phase constant and L is the length of the line, divided by ZC plus JZL tan beta L. So this is the formula for input impedance of a line as a function of the characteristic impedance, load impedance and phase constant and length of the line. Now beta L is 2 pi by lambda, since 2 pi by lambda is beta, the wave number, times length of the line, and lambda, that is the wavelength, is given by c by f, where c is the velocity of wave and f is the wave frequency. Now also you need to know impedance offered by capacitor is minus j times capacitive reactance, that is xc, which is 1 by omega c, and impedance offered by inductor is plus j xl, where xl is the inductive impedance or inductive reactance, where mod xl is omega l. Omega is the angular frequency of the wave and lc are line parameters. Now coming to the solution, we need to determine the input impedance. Now it is given that ZL is 0. Now we know Z input equal to characteristic impedance of line into load impedance plus Z characteristics tan beta L, divided by Z characteristics plus J load impedance times tan beta L. Now it is given ZL is 0 as we have already specified, so this becomes 0, this also becomes 0. You can cancel this and it is becoming JZC tan beta L, right? This is the input impedance which is it is reducing to. Now ZC is given to be 120 pi. This is given characteristic impedance of 120 pi ohms, so 120 pi is ZC. Now lambda equal to c by f, where c is the velocity of light because it is wave traveling with the speed of light, so c is 3 into 10 to the power 8 meters per second, divided by, all taking SI units, right? So f is given to be in the question as 37.5 megahertz, so 37.5 into 10 to the power 6 hertz. Now it should reduce to meter, since 1 by hertz is seconds, so it will cancel with seconds, and this is in meters, so it is coming as 8 meters. The length is given as 3 meters in the question. So now lambda is 8 meters determined. Beta L equal to 2 pi by lambda into L equal to 2 pi by lambda is 8 into L is 3, so it is coming as 3 pi by 4 beta L. So tan of beta L, as you need this, so tan of beta L I need to determine, which is coming as tan of 3 pi by 4, which is minus 1. Now coming to this one and putting the values, it is 120 pi, that is ZC, just refer from here, Z in is J times 120 pi into minus 1, so minus J 120 pi. Hence, since the input impedance is of minus J nature, we can easily comment that it is capacitive in nature. So input impedance is capacitive in nature, hence the option D is correct.